This is the UDK Material Editor video tutorial, part 1B. The version is UDK 2010-12. Team members are David DeCoster, Jado Ross, and Travis Everett. C15, and the date is 25th of January 2011. So what I'm going to go over in this section are just quickly some common material expression types. So to start off with, I have this really basic setup here. It uses a constant and an add. And what a constant is, it outputs a single float value. The expression is used basically to amplify any effect. So here we have an add expression, which is basically going to add the constant input with this texture. So to show you what I mean by that, here we have it set to 0. And when the 0 is added to the A channel and the texture is added to the B channel, the result is just the same texture, because this plus 0 equals this. However, if you change the constant to 0.5, you get this gray color, because now 0.5 white plus black equals this gray. Okay, so very similarly, we have the multiply expression. And what the multiply expression does is it works pretty similarly to the way multiply layer blends work in Photoshop. Basically, it takes this texture and multiplies it by this texture by kind of laying them over the top of each other. And usually it darkens it. So here we have the brick texture, and then you can see bits of the asphalt texture coming through on top of it. So if we delete the asphalt texture and then add in a constant, so say a constant of 1, the result is just the same brick texture, because this times 1 equals this. However, if you change the 1 to a 0, it goes black, because any number times 0 equals 0. In UK, in this instance, the 0 is equal to black. So that's a really quick, easy way to either mix different textures together or to lighten and darken. Okay. Next up, we have a constant 3 vector, which is this one right here. And it's like a regular constant, only you have inputs for the RG and B channels, or RG and B values, so you can change the color based on this. So right now we have it set 0.8, 0.2, and 0.6, which together equal this pink color. So when you pair that with an add between these two, the result is a pink smiley face. Okay, so if we hold Alt and break that off, we can add a similar one, which is called a vector parameter. And the way vector parameters works are they're very similar to the constant 3 vector, only since it's a parameter, you can name it and then go back and actually change it through coding in a material instance. If, say, you wanted to have different colors or different versions of the same smiley face, only at different colors, you would use a vector parameter, because you can create an instance and just change the color through there. But then an extra thing that is kind of special about this is it comes with a visual color picker, kind of similar to what you would use in Photoshop. So you can pick the colors visually instead of having to just do it randomly through number and kind of guess until you get the color you want. So it should be said that these take extra processing power, so they shouldn't be used unless they need to be used in like an instance. But it might be a good idea to keep one off to the side so that you can just pick colors visually and then figure out the RGB numbers, and type them into the other constant. Okay, so we'll delete that one and bring over this really simple one. This one is called 1 minus, and basically all it does is inverts whatever texture you plug into it. So here we have a white face on a black background. When you plug it into the 1 minus and into the diffuse, anything that was black turns white, and anything that was white turns black. Next up, we have a texture coordinate. And the thing about texture coordinates are they basically control how a texture is tiled across a surface. So if you go down here and with this highlighted to the parameter bar, under U tiling and V tiling, you set this to 4 and 4, and plug this in. The result is a 4x4 texture tiled across the surface of the cube. So you can basically type any number you want in there. So like here we have a 20x20 tiling. You can also do it so the values aren't equal, but it should be noted that it will result in stretching. So if you want to make sure that everything is uniform, just make sure those are always equal in value. Okay. So then next up we have a slightly more complex one, which is called a reflection vector. And basically what a reflection vector is used for is it's used often to fake environment maps. It involves using a normal map, in our case a specular. And what it does is a reflection vector simulates the way a camera's direction is reflected across the surface normal. So you have to run it through a mask and then hook it up to a texture sample, and then I have that running through a multiply for added color. Then you hook that up to the diffuse, and if you look at it when you rotate it, the reflection moves along the surface of the normals. There's another similar one called a camera vector, which also casts a reflection, except it's not broken up by the normals, so you don't get that realistic reflection. So camera vectors they're better used on very flat reflective surfaces where you would just have like a sheen, like maybe a piece of very smooth metal. And this is better used for bumpy surfaces. Okay, and then our final one is called a linear interpolation. And basically what it does is it combines these two textures along with an alpha map. So here we have a brick texture and an asphalt texture, and then the smiley face as an alpha. And what happens when we plug this in, anywhere that was black, the brick shows up, and anywhere that was white, the asphalt shows up. So it's just a nice, quick, easy way to create a mask for your shader. Okay, so in summary, those are just some of the basic material expressions. We'll go further into other ones later on in the other video tutorials, but the basis of all the more complex shaders are built on just these common expressions.